Now come to the base of the skull. In examination, vault or general discussion are not easily asked, or it is asked in case of person to person. It varied from examiner to examiner, but base of the skull is essential to pass the examination, and it is also a topic of fear in first year or second year medical student or anatomy student. First of all, we have to know the anatomical position of base of the skull. So in anatomical position of the base of the skull is the orbit lies in front. These are the orbit, this lies in front, and the Frankfurt's line lies in the same horizontal plane, and the alveolar arch is directed downwards. Now come to the Frankfurt's line. The Frankfurt's line is the orbitomeatal line, extend from the inferior margin of the orbit to the superior margin of external acoustic meatus. So in anthropological conference in Frankfurt, the city of Germany, it is adopted as the axis or the horizontal axis of the skull is the so it is known as Frankfurt's line. In examination, you may be asked the another line of anatomical position of base of the skull is raised base line. Which is that line? The raised base line extends from the inferior margin of the orbit to the center of the external acoustic meatus. Now come to the importance of the Frankfurt's line. The bones above the Frankfurt's line goes under the ossification of membranous ossification, and below the bones below the Frankfurt's line goes under the ossification of intracartilaginous ossification. Now come to the interior of the cranium or interior of the base of the skull. So in interior of the cranium, we can see some cranial fossa. Here we can divide the interior in 3 cranial fossa. Here is the anterior cranial fossa, middle cranial fossa, and posterior cranial fossa. And what are the boundaries between anterior, middle, and posterior cranial fossa? The anterior and middle cranial fossa are separated by the posterior margin of the laser wing of sphenoid, then sulcus chiasmaticus, then the posterior part of the posterior margin of the laser wing of sphenoid of the opposite side. The middle cranial fossa and the posterior cranial fossa are divided by a line extends from the superior margin of the petrous part of the temporal bone, then dorsum sella, then the superior margin of the petrous part of the temporal bone of opposite side. Now come to the content of this fossa. The anterior cranial fossa contain the frontal lobe of brains and some nerves. So here the frontal lobe is lodges in the anterior cranial fossa. The middle cranial fossa lodges the temporal lobe of the brain, and here is a fossa known as hypophyseal fossa, which lodges the hypophysis cerebri. The hypophyseal fossa is roofed by diaphragmacilla, which is a fold of meningeal layer of dura mater. In associated question, you may be asked in examination what is the blood supply of hypophysis cerebri, or what the another name of hypophysis cerebri, and the development of hypophysis cerebri. The hypophysis cerebri is also known as pituitary gland or the master gland of the body, and the blood supply of hypophysis cerebri is the superior and inferior hypophyseal artery branch of internal carotid artery, and the development of pituitary gland or hypophysis cerebri is morphologically divided into anterior lobe and posterior lobe. The anterior lobe is developed from the Rathke's pouch, and the posterior lobe is developed from downgrowth extension of neuroectoderm. Now some structures of middle cranial fossa. So here is a group which gives lodgement of the internal carotid artery with the sympathetic plexus, and the term Scilla turcica. The Scilla turcica is the structures of the sphenoid, which is consists of tuberculum scilla. Here is the tuberculum scilla, then the hypophyseal fossa, then dorsum scilla. These all are collectively known as Scilla turcica. The another thing is optic chiasma. The lodgement of optic chiasma is above the sulcus chiasmaticus. The sulcus chiasmaticus does not contain the chiasma of optic nerve. The chiasma situated above the sulcus chiasmaticus. Now come to the content of posterior cranial fossa. The posterior cranial fossa is the deepest fossa of the brain and the deepest fossa of the cranial cavity, and which is roofed by tentorium cerebelli. And here is the two transverse sulcus. Each sulcus gives attachment of tentorium cerebelli. The tentorium cerebelli is the fold of meninges. So the content of posterior cranial fossa is hindbrain, including cerebellum, medulla oblongata, then pons. The term clavus. This is the clavus, which is formed by body of the sphenoid and the basi occiput, or the part of occipital bones. And the relation of the clavus is very important, and the clavus is related with pons and medulla oblongata, which is separated by basilar venous plexus and basilar artery. And the another thing is here, this is the internal occipital protuberance, which is important because this is known as the confluence of venous sinus of brain. Now come to the most important topic of base of the skull. We say this as foramenology or some foramens. The base of the skull contains like 85 foramens. So 85 foramina are not important for us. The important foramina are discussed in this tutorial. So first of all, we have to know the foramen cecum. This is the foramen cecum, the most anterior foramen of the base of the skull. The content of the structure passing through the foramen cecum is the emissary vein, which connect the veins of the roof of the nose and the superior sagittal sinus. Then the portion is known as cubiform plate, and this is cubiform plate. These are the cubiform plate, and cubiform plate transmits the olfactory nerves. So we know the first cranial nerve are transmitted through this cubiform plate. Then the optic canal. This is optic canal, and optic canal transmits the optic nerve or second cranial nerve and ophthalmic artery. The ophthalmic artery is the branch of internal carotid artery. Now come to the superior orbital fissure, and this is the superior orbital fissure. This is the superior orbital fissure, and superior orbital fissure is formed by the greater wing of a slit, a transverse slit between greater wing of sphenoid and lesser wing of sphenoid, and this slit is divided into three compartments: superior lateral compartment, intermediate compartment, and inferior compartment by a tendinous ring, which gives the origin of the extraocular muscles. So the content of the superior lateral compartment is the lacrimal nerve, the frontal nerve, and the trochlear nerve. The lacrimal nerve and frontal nerve are the branches of fifth cranial nerve or the trigeminal nerve, and the trochlear nerve is the fourth cranial nerve. So the content of superior lateral compartment of superior orbital fissure is can be remembered by the mnemonic LFT. LFT is the mnemonic for liver function test. So in anatomy we can use this as the mnemonic for the content of superior lateral compartment of superior orbital fissure. Then come to the intermediate compartment. The intermediate compartment transmits the oculomotor nerve, which is the third cranial nerve, and the abducens nerve, which is the sixth cranial nerve, and the another part of fifth cranial nerve, that is trigeminal nerve, and the intermediate compartment transmits the nasociliary branch of trigeminal nerve. And the inferomedial compartment, the most medial compartment of superior orbital fissure, is inferomedial compartment, which transmits inferior ophthalmic vein and superior nervous plexus. Now come to the foramen rotundum. There is a rounded foramen, and this is known as foramen rotundum. Foramen rotundum transmit maxillary nerve, branch of fifth cranial nerve. Now come to the foramen ovale. This foramen, named after its shape, as it is the oval shape, so it is known as foramen ovale. Foramen ovale transmits the mandibular nerve, the accessory meningeal artery, the laser petrosal nerve, and the emissary vein connected the pterygoid venous plexus and the cavernous sinus. So the content of the foramen ovale are remembered by the mnemonic MALE, M-A-L-E. M for maxillary nerve, A for accessory meningeal artery, L for laser petrosal nerve, and E for emissary vein, which connects the pterygoid venous plexus and cavernous sinus. Then foramen spinosum. This is the small foramen. This is known as foramen spinosum, as it is situated close to the spine of the sphenoid, so it is known as foramen spinosum. So all the structure passed through the foramen spinosum is named with M. So the content of foramen spinosum is 3M. That are the middle meningeal artery, middle meningeal vein, meningeal branch of mandibular nerve. Now come to the foramen lacerum. This is a important foramina for sphenoid and also for base of the skull. So the foramen lacerum, this is the foramen lacerum, which is formed by the anterior end of the petrous part of the temporal bone and the body of the sphenoid. The foramen lacerum transmits the internal carotid artery, then meningeal branch of ascending pharyngeal artery, then greater petrosal nerve, then emissary vein, which connects the pharyngeal venous plexus and cavernous sinus. And the content of the foramen lacerum can be remembered by a mnemonic known as IMAGE, I-M-A-G-E. I for internal carotid artery, M for meningeal branch of ascending pharyngeal artery, then G for petrosal nerve, then E for emissary vein. So these are the contents of foramen lacerum. Then here is a depression, so in the petrous part of the temporal bone. Here is the depression known as a trigeminal fossa, which lodges the trigeminal ganglion. This is not important for examination. The most important for examination is the internal acoustic meatus. These are the internal acoustic meatus, which transmits the facial nerve, which is 7th cranial nerve, then vestibulocochlear nerve, that means 8th cranial nerves, then labyrinthine vessels. Next, the jugular foramen. So this is the jugular foramen, is formed by above by petrous part of the temporal bone, below the jugular fossa of occipital bones. So this is the jugular foramen. This jugular foramen is also divided into 3 parts: the anterior, posterior, and middle part. The most important part is the middle part. The middle part of the jugular foramen transmits the 9th, 10th, and 11th cranial nerve. That means glossopharyngeal nerve, vagus nerve, and accessory nerves. And the anterior compartment of the jugular foramen transmits the inferior petrosal sinus and meningeal branch of ascending pharyngeal artery. The posterior compartment of the jugular foramen transmits the sigmoid sinus and the meningeal branch of occipital artery. And interesting topic is in the posterior compartment of jugular foramen, the sigmoid sinus is converted as vein named as internal jugular vein, and we discussed this in the angiology portion of the base. Now come to the hypoglossal canal, and this is hypoglossal canal. This is hypoglossal canal. Here is the hypoglossal canal. So the content of the hypoglossal canal are hypoglossal nerve, that means 12th cranial nerve, emissary vein which connects the internal jugular vein and sigmoid sinus, meningeal branch of ascending pharyngeal artery, then diploic vein. The mnemonic for hypoglossal canal is HEMAD, H-E-M-A-D. H for hypoglossal nerve, E for emissary vein, M-A for meningeal branch of ascending pharyngeal artery, then D for diploic vein. Now come to the foramens of the inferior part of the base of the skull. So this is mastoid foramen. So the content of the mastoid foramen is emissary vein to which connect the veins of scalp and transverse sinus. And now come to the most important foramen, or the largest foramen of the skull, is known as the foramen magnum. And the foramen magnum is divided into two compartments, anterior and posterior compartment, by the alar ligament. As we know, the alar ligament is attached to the condyle of the occipital bones. So the anterior compartment, which is known as the osseofibrous compartment, and the posterior compartment is known as the neurovascular compartment. So the anterior compartment transmits the apical ligament, the occasionally tip of dens. The tip of dens means the axis, and tip of dens means the odontoid process of the axis. Then the upper vertical ligament of the cruciate ligament, membrana tectoria. And these structures are aligned as before backwards. So before backwards, the anterior compartment of the foramen magnum transmits the apical ligament, then upper vertical band of cruciate ligament, then membrana tectoria, and the posterior neurovascular compartment transmits the lower portion of the medulla oblongata, and this is the actually the demarcating line between the medulla oblongata and the spinal cord. The lower margin of the foramen magnum is the demarcating line. The above the lower margin of the foramen magnum, or the portion of the central nervous system, is known as the medulla oblongata, and the lower portion of the inferior margin of the foramen magnum is known as spinal cord. Then sometimes tonsil of cerebellum may protrude through the foramen magnum occasionally, and the subarachnoid spaces also transmit through this canal. And the ascending parts, the fourth part of the vertebral artery ascends through the posterior neurovascular compartment and with sympathetic plexus, and then spinal root of accessory nerves. So now come to the carotid canal. So this is carotid canal. This is inferior opening of carotid canal, and this is anterior opening of carotid canal. Carotid canal transmits internal carotid artery with sympathetic plexus. Then comes to the stylomastoid foramen. This is stylomastoid foramen, and each stylomastoid foramen transmits the seventh cranial nerve, that means facial nerve, and stylomastoid branch of posterior auricular artery. Then anterior to the base of the skull. Anteriorly, here is the superior orbital foramen and supraorbital foramen. Actually, this is supraorbital foramen. Supraorbital foramen transmits superior orbital nerve and superior orbital vessel. Then this is infraorbital foramen. Infraorbital foramen transmits inferior orbital nerve and inferior orbital vessel. Actually, the infraorbital foramen is firstly it is known as the infraorbital group situated in the floor of the orbit, then infraorbital canal, and terminate as the intraorbital foramen. All of them are contain the inferior orbital nerve and inferior orbital vessel. The another foramen is zygomatic foramen. This is zygomatic foramen, and the content of zygomatic foramen is zygomatic nerve and zygomatic vessel. This is all about foramenology, and now this topic is very important for examination. Show the entrance of the all 12 cranial nerves. So the first cranial nerve, known as olfactory nerve, which enters into the cranial cavity through the cibriform plate. So this is cibriform plate, and through this cibriform plate 15 to 20 fasciculi of olfactory nerve are transmitted through cibriform plate. Then second cranial nerve, that is optic nerve, which enters into the cranial cavity through the optic canal. So this is the optic canal. Then third cranial nerve, through the intermediate compartment of superior orbital fissure. Then fourth cranial nerve, which transmits the superior lateral compartment of the superior orbital fissure. And now come to the trigeminal nerve or fifth cranial nerve, which actually divides into three divisions: ophthalmic division, maxillary division, mandibular division. The mandibular division transmits through the foramen ovale. So this is the foramen ovale. The maxillary division or the maxillary nerve is transmitted through the foramen rotundum, and the ophthalmic division again divides into three nerves: nasociliary nerve, lacrimal nerve, and the frontal branch. The lacrimal branch and frontal branch of ophthalmic nerve transmits through the superior orbital fissure, and the nasociliary nerve transmits through the intermediate compartment of the superior orbital fissure. Now come to the sixth cranial nerve. Sixth cranial nerve or the abducens nerve transmit through the intermediate compartment of superior orbital fissure. Now come to the seventh cranial nerve or facial nerve, which exits the cranial cavity through the internal acoustic meatus, then the stylomastoid foramen, which transmits through the facial canal, which presents within the petrous part of the temporal bones. Now come to the eighth cranial nerve. Eighth cranial nerve is the sensory nerve, known as the vestibulocochlear nerve, which enters into the cranial cavity through the internal acoustic meatus. 9th, 10th and 11th cranial nerve, known as glossopharyngeal nerve, vagus nerve and accessory nerve, are exits the cranial cavity through the intermediate compartment of jugular foramen, and the last one, the hypoglossal nerve, transmits through the hypoglossal canal, that is hypoglossal canal. This is all about foramenology. Now come to the angiology of base of the skull. Angiology means vessels. In base of the skull we see some impressions for vessels. These are the impression for medial meningeal vessel. These all are the impression for medial meningeal vessel. Another question in students, the why these portion of the base of the skull are grouped, and why these are not uniform. Due to lodgement of the gyrus and fissures of the brain, the interior of the base of the skull is not uniform in shape. And now come to the sinus and venous sinus. The venous sinus is very important for examination. First of all, what is the basic difference between venous sinus and vein? The sinus are the dilated vein, and which contains the blood with CSF. Actually, the other veins of the body does not contain any CSF, but the blood of the venous sinus contains CSF. What are the venous sinuses within the cranial cavity? About 23 venous sinuses are present in the cranial cavity, and all of them, some are paired sinus and some are unpaired sinus. The paired sinuses are the transverse sinus, sigmoid sinus, cavernous sinus, superior petrosal, inferior petrosal sinus, sphenoparietal, petrosquamous sinus, then medial meningeal sinus. And the unpaired sinuses are the superior sagittal sinus, inferior sagittal sinus, straight sinus, occipital sinus, anterior and posterior intercavernous sinus, then basilar venous plexus. Now come to the what are the situation of these venous sinuses. In besides the body of the sphenoid, here the most common sinuses are present, which is the cavernous sinus. In examination you may be asked why cavernous sinus is known as cavernous sinus. The cavernous means spongy. The appearance of the sinus in dissection of the cadaver, it is spongy due to presence of many reticular fiber. And this is very paid question for examination, is that what are the structures passing through the cavernous sinus? The structures which passing through the center of the sinuses are internal carotid artery and sixth cranial nerve, that is abducens nerve. And the structures which pierce the lateral wall of the sinus are third, fourth and fifth cranial nerve, that means oculomotor nerve, trochlear nerve, and ophthalmic division of the trigeminal nerve and maxillary division of the trigeminal nerve. From this we can understand that any lesion in case of cavernous sinus leads to the third, fourth, fifth and sixth cranial nerve palsy. Now come to the connection of the cavernous sinus. The cavernous sinus may be connected with the sigmoid sinus. It also connected with the superior sagittal sinus, and it also may be connected with the directly through the internal jugular vein. It also connected to facial nerve, facial vein. So now come to the important sinuses. The presence of the important sinuses are in the superior sagittal sulcus. It contains the superior sagittal sinus, which terminates in the left transverse sinus, and the superior sagittal sinus is situated within the fox cerebri, and the fox cerebri has two parts, which is one is attached border, another is free border. The free border of the fox cerebri contains the inferior sagittal sinus. The inferior sagittal sinus is continuous as straight sinus. Then the straight sinus is located here. So its straight sinus terminate in the right transverse sinus. So here is the internal occipital protuberance, which is known as the venous confluence of the venous sinuses. From here the left transverse sinus passes through the left transverse sulcus, and the right transverse sinus passes through the right transverse sulcus. Then the transverse sulcus is continued as sigmoid sulcus. Here is the sigmoid sinus. So here is the sigmoid sulcus, which contains the sigmoid sinus. Each sigmoid sinus is continuous as the internal jugular vein, and which exits the cranial cavity as internal jugular vein, and then drains into drains into the superior vena cava. This is all about the base of the skull and the vault of the skull and general discussion on skull. If you have any confusion or any question about the skull bones, you may comment on the comment box or may post in the Kalosam BD study group. Thanks everyone.